Let's talk about trying to understand the Phoenix site by comparing it to polar regions on Earth. I made the case that 5 million years ago, the Phoenix site got as much sunlight as polar regions on Earth get today. I want to carry that logic a little further. So this is a diagram that I used to think about that, where I have drier on one axis and colder on the other. And up here in the extreme corner, cold and dry, is Mars today. It's colder and drier than anything we have on Earth. And on Earth, I want to start down here in the corner in the Arctic. This is actually a picture from Eureka, up in the high Canadian Arctic. And it's fairly cold, but it's warm and wet as polar regions go. And you can even see a little bunny rabbit here, indicating how hospitable it really is. But then if we go to colder and drier, we can go to Antarctica. The coastal regions of Antarctica are colder and drier. Then if we go high in the mountains in Antarctica, 1.5 kilometers or more above the sea level, we get to the coldest, driest places on Earth. In particular, this valley, University Valley, which has got very nice examples of this extremely cold, dry permafrost. And we cross a boundary. We cross the boundary between liquid permafrost and vapor permafrost. What I mean by liquid permafrost is permafrost, that ice-cemented ground that in the summer warms up and creates a layer of liquid, bulk liquid, between the surface and the ice table. So the contact between the ice and the ground above it has liquid water, and the contact's at 0 degrees. It gets muddy in permafrost. Everywhere in the Arctic in the summer, it's muddy. Everywhere in the coastal Antarctic, it's muddy in the summer. The only place where the permafrost never has, where the ice-cemented ground really never has a liquid phase, is here in the high elevations of the Antarctic, where we have only solid ice and vapor. The ice-cemented ground exchanges with the environment only through vapor, never with bulk liquid. This is the most Mars-like permafrost we have. It's still not as cold and dry as Mars today, but it's as cold as dry as Mars 5 million years ago. So ice-cemented ground and permafrost on Earth brackets Mars 5 million years ago, but it doesn't reach to Mars today. So if we study the range of physics and biology of permafrost on Earth, we can say something about 5 million years ago. We probably don't reach Mars today. So that's what I want to do. So we go to the dry valleys. This is a Landsat view of the dry valleys, the largest ice-free region in Antarctica. Here's the coast of Antarctica. Here is Ross Island. This little black smudge is the tip of Ross Island, Hunt Point, which has 2 bases on it, the New Zealand base and the American base. And you can see the icebreaker track going in. This is a picture in January. Icebreaker track going in, taking supplies to the base. We fly out from there to this region, this big, dry region, ice-free region, very cold. It's the one place on Earth where it never rains, only snows. And yet there are huge rivers and lakes and glaciers. Rivers and lakes without rain. And it works on a snow-based hydrological cycle. There's ice-covered lakes which evaporate, making snow, which precipitate to make glaciers, which flow, and then seasonal melting causes seasonal rivers, which form ice-covered lakes. And Calvin and Hobbes are in there for scale. So this is the only place on Earth where there's a hydrological cycle which does not ever involve rain. Even if you go to the driest deserts on Earth, the Atacama Desert, there's not much of a hydrological cycle there, but the hydrological cycle that does occur is still based on rain. This is the only place where we have one that's based on snow. And I think that that's a model for Mars. So I'll quickly tell you how we get to the Antarctic. You fly from Christchurch, New Zealand, on Air Force planes, like for example these 130s with skis in front, land on snow. We go to McMurdo Station, which is a huge base. In the summertime, which is November, December, and January, there will be 1,000 people at this base. 1,000 people in Antarctica. We're not interested in being in McMurdo very long. We load up camping gear in helicopters, fly out, cross McMurdo Sound to the dry valleys. After we've gone through survival school, where we learn how to build snow forts. which is not a very useful skill in the dry valleys. There's no snow, they're dry. But they teach us this anyway. It's a lot of fun playing with snow when you're from California. It's a rare treat.
The novelty wears off.
I imagine, yeah, I know. I lived in Colorado when I first started going to Antarctica, and it was just in one cold region to another. Here's a typical camp. That's my room there. This is the facilities. Everything we generate, all waste is taken out. All solid, all liquid waste is carried out. Because this environment, the mean annual temperature is minus 20 centigrade, which is about the mean temperature in a freezer. You put stuff in the freezer, it doesn't decompose. You come back 5 years later, it's still there, frozen. It's not very helpful. So we carry everything out. Every drop of waste carries out with it. So this is the U bottle, and this is the number 210. All of the waste is separated at the source. So we ship them out. And here's the view from the tent, looking there. And so the year, while Phoenix was in flight, while Phoenix was flying to Mars, we went down to Antarctica. I took the Phoenix team. Here's Peter Smith, the PI, and some other members of the team. I'm the local guy. The idea was to take them down and do what their instrument was going to do on Mars. What the spacecraft was going to do on Mars, we were going to do on Earth. Ostensibly, it was to test the instruments, but in reality, it was to build up an experience of these polar environments. Peter was the PI. He's from Tucson, Arizona. He's a Phoenix PI, but from Tucson, Arizona, University of Arizona. Tucson, Arizona is not known for permafrost. There's tremendous grass. And some of these people had never been in the polar regions before. And they were going to operate the spacecraft in the polar regions on Mars. So what I thought was useful to do was to just literally do with their hands what the spacecraft was going to do and to build up that intuition that you get when you work in an environment. It's kind of like riding a bike. No amount of explaining is a substitute for actually doing it. And the idea was to actually do it, take them out and do it. So that's what we did. I want to show you the results. So first, we set up a camp on the shore of Lake Frixell, which is coastal permafrost. And we picked this camp, I picked this camp for two reasons. One is it's a really cushy camp, it's a nice camp. It's right on the coast. It's got a structure here that's solar powered, indoor, sit at the table. We had a Christmas dinner in here. It's really kind of nice. In fact, we have wireless internet. I'm not kidding. You can set up your tent. I have my tent right here. Sit down in your tent, open your laptop, and you have wireless internet.
And there's like no interference.
And it's pretty clean, you know, when it works. And you can see the pattern ground here. This is permafrost. It's typical wet permafrost, which means in the summer, it looks like this. The surface can warm up above zero, and there's a layer of dry soil. It's a desert after all, so it's a layer of dry soil. But then there's a layer of wet soil, and then there's the ice-cemented soil, and the temperature between the wet soil and the ice-cemented soil is 0 degrees. This is typical wet permafrost in a desert environment. And that's what we saw here, and we sampled that. It's also a good place to take the team first because none of the other members of the team had ever been to Antarctica before. So this was an easy starting spot. But then